out of his office, and he wrote down a plan for me, and I did it. And then when I got to the end of undergrad, I went, do I want to study physics or do I want to study biochemistry? And I'd worked in a physics lab and I'd worked in a biochemistry lab, and physics smells better. I had worked with chloroform every day. Yeah, physics is a lot of fun. I did undergraduate research. I did 4 different programs. I was indecisive. I did some undergraduate research actually at UNC Chapel Hill, but not in physics. Colorado State, where I went to undergrad. I went off to the Netherlands for 5 months. I went to Switzerland, and I had a lot of fun. So if you haven't done these, do them, and go find out. Sometimes the most important thing you find out is that you absolutely hate something and you don't want to do it for the rest of your life. When I started the field that I'm in now, I'd always been excited by things that are very small, but I'd heard these things like, oh, I don't want to work in a large collaboration, I don't want to work with 1,000 people, I don't want to sit in front of a computer all day. But I was so fascinated by it that I decided that I would just sit down and try it, and I absolutely loved it. I loved programming. I found out I was good at it. It isn't for everybody, but that's okay. And it's a lifestyle. So I spent about 4 months out of town last year. I racked up 40,000 airline miles. Of course, this was the last year when we had the first collisions. Our detector that I'm working on is going in actually right now, and I'm going back on Saturday to finish hooking up all the cables. So there's reasons why this has been a busier year. That doesn't have to be, it doesn't have to be 40,000 miles a year and 4 months out of town. But I also went to CERN, to Switzerland, I went to Italy. It's been a blast. I wouldn't give it up. My husband is Czech. I met him when I was a summer student at CERN. I wouldn't recommend using these as dating programs, but it wasn't really planned. And he lives in New York. We haven't managed to get jobs together. A lot of women in physics go through a phase like this. And we went to visit a nuclear reactor on our honeymoon. To get him to agree to go to Yellowstone, I had to agree to go to EBR-1, Experimental Breeder Reactor 1, out in Idaho National Lab. And we got back, and this is what he was bragging about. Not, we saw Yellowstone, but we saw EBR-1! It's great. And this is kind of what I spend my time doing. My analysis is all done programming, but I actually now spend about maybe 30% of my time doing analysis. I write and I give a lot of talks. So in the last year, I gave 3 research talks, 1 seminar, 2 post-throughs, a software tutorial, and that's just things that are kind of formal. At internal Elise meetings, I probably gave over 30 talks. Well, Elise meetings, group meetings, I give talks all the time. I do hardware work, so this is me in front of one of our detectors. This was taken at 1 o'clock in the morning because you do shifts, you run things 24/7, so you have to go take data when there's beam. I work with graduate students. Here you can see me with one of our graduate students at my office at the National Lab. There's a pond out in front of my window, so this is where I go all the time. Baby geese, it's cool. And then I also do stuff like outreach. I got talked into being a blogger for Elise USA, which after I agreed to it, I realized there were 20,000 Facebook followers and 5,000 hits a day to the blog. I didn't really know what I was getting into, but it's been a lot of fun. I've also given tours of one of the experiments to the public. I review a lot of the work of my collaborators. I am a native English speaker, so I check a lot of English. And especially my husband being Czech, occasionally I get the "you're the only native English speaker I know, can you please help me?" I've used that a lot more than I thought I would. And kind of, these will be on the web, so if you want to come back and look at this, if you like these things, if you like programming, if you like giving talks, if you're a people person, I think people underestimate this, but you really kind of have to be a people person to do this job, because you work with 1,000 people. You have to get along with them. But things that people do after this field, there's of course academia, both research and teaching universities. You can work at a national laboratory. This is more of a 9-to-5 job. It can be. You can work as long hours as you want, but they tend to be more 9-to-5 jobs. They hire people starting at all levels. So I've actually run into some people I know who started working at an accelerator right after their bachelor's degree. I know quite a few people who have gone to do defense work, and a lot of people go into finance, being the quants, who calculate things for the people working in banks. They've not hired as many people recently. They probably will at some point in the future. And then people go into computer programming. What's missing from here is that there's not a lot of people going and working for private companies doing physics. You can do that, but with this background, most people then go and move more into low energy nuclear. So there's fewer options in industries than this. And these are all links to different pages to learn more about the subject. And I've got a couple pages on what programs exist in the United States doing high energy nuclear physics. Thank you. Question? Go ahead.
Two thoughts. One, you gotta see something about the Large Hadron Collider. The Large Hadron Collider. Come on. You guys can Google that. So yeah, I think it's a lot of fun. There's a rap song that people did for this.
And a bunch of the grad students did it.
Yeah. So anyway, I think it's great. It's a lot of fun. Physicists are cool. That's what we're going to show. The question that I actually have, Rick, the relativistic heavy ion story, showed that there was, there's a lot of different results from Rick. What happened at Rick? Can you explain what happened at Rick and why there's so many people on higher energies and the difference between studying quark gluon at Rick and doing quark gluon?
Okay, so what you're used to thinking of high energy as, they're looking for new particles. So what you've heard about is the Higgs. And to study for new particles, you have to go higher in energy. The point of high energy nuclear physics, what we do is actually to study the properties of this phase of matter called quark-gluon plasma. So we're interested in moving all around the phase diagram. So actually at RIP they went back and did lower energy measurements too, because we're trying to study everything in phase space. The Large Hadron, so what happened at RIC is that we kind of decided as a community, yes, we really have seen the quark-gluon plasma. We must be high enough in energy Um,